Okay, circle geometry. Under this topic, we're going to look at the path of a circle, length of an arc, area of a sector, area of a segment, length of a chord, and tangent of a circle from an external point. So let's look at paths of a circle. So I know before now you've heard of circumference, circumference of a circle, radius of a circle, arc. So look at the diagram. The circumference of a circle is just the distance around the circle. Besides, a circle is just a collection of points equidistant from a fixed point. So if you have some points, collection of these points equidistant from this fixed point. The fixed point is this center O. So if you collect those points, you form a circle. So a circle is just a locus of points or collection of points equidistant from a fixed point. So once you collect those points, you form a circle. Circumference of a circle is just the distance around that circle. Why the radius? Radius is just the distance from the center to a point on the circumference. So I'm saying that OA, that's OA here, is the radius of the circle. Why the diameter is 2 times the distance from 2 points on the circumference that passes through the center. So if you have, so I'm saying that AD is the diameter because the distance from A to D passes through the center. So AD is our diameter. So AD is the diameter. Saying that OA or AO is the radius, while AD is the diameter. So arc, we have major and minor arc. So the minor arc is like AB. AB is a minor arc. This is a minor arc. So I'm saying that AB is a minor arc. While ACB is a major arc. So ACB is what? A major arc. So the one that contains if you look at angle alpha and angle beta, so this one is smaller than this. So this AB is our minor arc. And we normally represent it as AB with something on top like this. It's denoted by this. Why the major? So major has three letters. Why minor has one letter. So that's how you know the major and minor arc. So coming to sector. Sector is just a portion of area of that circle, because area of a circle is just this portion. Everything here is the area of the circle. So just a portion of that is the sector. So I'm saying that area AOB is a sector, but it's a minor sector because it contains the minor and the smaller angle. Why the major one is the one formed by beta. So that's the minor and major sector. With that, you can easily see that the area, since we know that circumference of a circle is, let's now write the formula for the length of arc, and area, that's area of a sector. So Since we know that circumference of a circle, we've known that of a circle is always 2 pi r, or maybe pi d, because we know that d is 2 times r, diameter is 2 times radius, and we know that area of a circle is always pi r squared, or maybe in terms of diameter, pi d over 2 squared, which is pi d squared over 4. So it's either this or this. And since arc, length of arc now, arc is a portion of the circumference. So we now see that since the angle formed by this arc, minor arc, is alpha, so we see that the length of arc is alpha over 360 times 2 pi r, just a portion of the circumference. So that's for arc AB. But for arc ACB, that's the major one, is beta over 360 degrees times 2 pi r. And you know, beta could be written as 360 minus alpha. So in most cases, they won't give you beta. They might give you alpha, minor arc. That's the angle for the minor arc. So anyone, this alpha. So that's the formula for length of arc. Y, area of a sector. A sector is a portion of a circle. So we still have it as, if it's for minor sector, is alpha over 360 times pi r squared. But if it's for major sector, the big one, or the bigger one, we have beta over what? 360 times pi r squared. So coming to segment. A segment is inside a sector. So see what I'm saying? So we have the major segment, we have the minor segment. So you can easily see that if I want to get the minor segment, is just subtract this triangle. So assuming I have triangle, I have a triangle where radius, that is a circle with radius r that formed a triangle. That's the chord, and the chord and the length of chord and the radius form the triangle. So what you have to do, you subtract the area of this triangle from the sector, you get the area of a segment. So I'm saying that the area of, I'm using the minor segment now, is, okay, assuming I have the angle here to be maybe alpha. So alpha over what? 360 times pi r squared. This is the area of a sector. I told you, to get the area of a segment is area of a sector minus area of the triangle AOB. So that's what I'm doing, minus area of this triangle is, remember, this side angle side, so it's half r squared sine alpha. Do you remember, if you are given two sides and an included angle, the area of the triangle is half times the product of the two given sides times the sine of the given angle. So that's it. So that's for minor segment. So if you want to get for major, it's very simple. For major, it's just the area of a circle minus area of the minor one. So once you've known the portion, this minor one, you subtract the area of the minor segment from the area of the circle, you now get your area of major segment. So that's it. So let's go over to length of chord. So a chord is just the distance between two points on the circumference. So we can still see that a diameter is a special type of chord. So assuming the length of this chord is L, so AB want to get the chord length of this chord. So we join the radius. As you can see, we form an isosceles triangle. And you know one characteristic of an isosceles triangle, the height is a perpendicular bisector. So it has bisected the angle theta to be theta half, that's half theta. So our main aim is to get the L, that's an expression for L. So from this you can easily see that in triangle OCB, that we are given the hypotenuse and we are given the opposite. So we see that sine half theta is opposite, which is L over 2 over what? Adjacent over hypotenuse. So which is the same as L over 2R. Therefore, making L, which is length of chord, L is the length of chord, is now 2R sine half theta. So that's the expression for the length of chord. So each time you're asked to find the length of chord, that's the formula you use. 2 times the radius times the sine of the half of the angle, central angle, the minor one. So that's it. Okay, let's look at external segment. That's what we have done is just remaining this. So let's look at tangents of a circle from an external point. After we now solve we'll solve general question on this.